Welcome to Joystick, my friend. In this video, we'll look into creating a program to check prime numbers. The program is going to take a number from the console and it is going to tell if that number is a prime number or not. A prime number is a number that is divisible only by 1 and the number itself. A prime number doesn't have any third factor. Examples are 2, 3, 5, 11, 7 and 19. Alright, let's start coding the program in the PyCharm IDE. But before that, if you're new to my channel, then hit the subscribe button and the bell icon, because that way you won't miss out on any new videos of Python coding interview questions I create. We begin with writing the main function first. So I'm going to type main, and there you go, main function created. Then we write the code to take the number which we have to check from the console. So I will declare a variable. It will be v_num followed by n equals to sign. We will write input, and within its brackets we'll enter a message, enter the number. You can see we are making use of the input function to take the input. Of course, we'll have to typecast the input into integer because the input function always returns a string. Now we'll run a loop from 2 to the value 1 less than this number stored in v_num. So if the number is 5, then the loop will run from 2 to 4. So it will be for I in range 2, v_num. There you go. Within the for loop, we'll write a line of code that finds the remainder calculated by dividing the number entered, which is stored in v_num, by I. I is the value that increments from 2 to the value of 1 less than the value stored in v_num with each iteration of the for loop. And we'll store the remainder in a new variable v_rem. So let's declare that variable v_rem followed by n equals to sign. We'll write v_num modulo operator I. That's it. If the remainder comes out as 0, it means that the number is divisible by any integer which is different than itself and 1. And thus we flag this number as not a prime number. So we declare a flag over here and initialize it to false. Let's call this flag as flag_prime and let's initialize it to false. Okay. Now we put a check over here within the for loop that if v_rem equals to 0, then we set the flag to true. So it will be flag_prime. After the equals to sign, we are going to write true. So if the remainder is calculated as 0, then we are going to flag this number as not a prime number by setting flag_prime as true. Once the flag is set to true, there is no use in checking the further iterations. Hence we break out of this for loop using the break statement. So beneath this line of code, we'll write break, and that's it. So if the remainder is calculated as 0, then the flag_prime will be set to true, and also we are going to come out of the for loop using this break statement. After the for loop, we put an if else that says if the flag_prime is true, we print that v_num is not a prime number, else v_num is a prime number. So let's write the code for it. So it will be if we are going to simply write flag_prime. This syntax is going to check if flag_prime is true or not. So if it is true, then we are going to print curly braces is not a prime number, and within format, of course, we are going to pass v_num, and in the else part we are going to copy and paste this line of code, and we'll simply remove not. So it becomes v_num is a prime number if flag_prime is false. And that's it. Program is over. Let's run the program and check the output. Alright, So it is asking me to enter the number. Let me enter 5, which is a prime number, and let's see if the program recognizes it or not. There you go. It says 5 is a prime number. Let me do another run, and this time with 4. Okay, so it says 4 is not a prime number. Now there are a couple of optimizations we can apply to this program that I want to share with you, but before that we need to make sure that we only run this whole operation for a number that is greater than 1. Thus we'll put a check over here. So the check will be if v_num is less than equals to 1, then we print enter a number greater than 1 and we exit the program, or else the program continues. So this check is mandatory. Now let's discuss the optimizations. We need not run the for loop till the number that is 1 less than the number we are checking. For example, if the number we are checking is 10, we don't have to run the loop from 2 to 9. We only have to run the loop from 2 to 5. 2 is the lowest factor a number can have when we are not considering 1, right? So the maximum factor with which the division is possible is the number itself divided by 2, which in this case is 5. Hence, the loop has to run from 2 to 5 when the number is 10. So we will change the end parameter of the range function to v_num 2 times /2 plus 1. Alright, I'm going to take this one into brackets. Note that I am using double forward slashes. That means I want an integer, not a float. Let's run the program again and check the output. Okay, so it is asking me to enter the number. Let me enter 8. It says 8 is not a prime number. Let me run the program again. It's asking me to enter the number again. Let me enter 7. And it says 7 is a prime number. So what this has done, this has made our program a little bit faster. Another optimization that you should know to make this program run faster is to run this loop from 2 to the square root of the number entered. So I'm going to make a little change to this final parameter of the range function. Let's change it to pop v_num, 0.5. This is going to calculate the square root. And of course, we'll have to typecast it into integer. We don't want float values to be calculated and complicate things. And of course, I'm going to add 1 to it because the loop must run from 2 to the square root of the number. Let's run the program again and check the output. Okay, this time I'm going to enter 17. Alright, it says 17 is a prime number. Let's run the program again. Let me enter 26. And it says 26 is not a prime number. Let me enter 93 this time. And it says 93 is not a prime number, which indeed it is not. Let's now enter 89, which will be our final test case. And it says 89 is a prime number, which indeed it is. So you can see that the program is running fine with this optimization as well. With this, we have come to the end of this video. I hope you enjoyed watching it, and I hope you learned how to check whether a number is a prime number in Python. Do give this video a thumbs up, share it with your friends and colleagues. I'll see you in the next video of Choice Tech. Goodbye and take very good care of yourself.